We've all been told the universe is everything. The galaxies, the stars, the atoms making up your body, all of it together forms reality. But what if that's the greatest illusion of all time? What if our universe is just one slice in a vast, hidden structure of countless realities stacked beside each other? In quantum physics, this isn't science fiction. It's a serious question tearing physicists apart. Does reality collapse into one definite version when we look at it? Or do infinite versions of reality keep existing in parallel, branching endlessly, whether we notice them or not? Picture this. You flip a coin. In our ordinary world, it lands heads or tails. End of story. But quantum mechanics doesn't play by ordinary rules. At the tiniest scales of particles, both outcomes exist at once, heads and tails, until something forces a decision. That decision could mean the collapse of possibilities into one reality. Or it could mean something much stranger, that both outcomes become real in different universes, with two versions of you watching two different results. This is not just a philosophical game. It's the battleground of two of the most radical interpretations of quantum mechanics. The Copenhagen interpretation, where wave functions collapse into a single outcome, and the many worlds interpretation, where collapse never happens and every possibility continues to exist. One is a universe that resolves itself. The other is an infinite explosion of realities, unceasing, unimaginably vast. And here's the terrifying twist. If the multiverse picture is true, then right now, as you watch this, infinite versions of you are living out infinite different lives, some almost identical, others utterly alien. So the question becomes, are we the lucky observers of one unique reality? Or are we prisoners wandering inside an endless multiverse we can't escape? To even begin to answer whether we live inside a quantum multiverse, we have to face the strangest feature of quantum mechanics, superposition. At the subatomic level, particles don't behave like little billiard balls moving in neat trajectories. They exist in waves of probability, overlapping possibilities of being here and there, spinning up and spinning down all at once. Mathematically, we can describe this with the famous Schrödinger wave function, which encodes every possible state a particle could occupy. But here's the puzzle. When we measure that particle, the blurry cloud of probabilities seems to snap into one outcome. The wave function collapses. You check the spin. It's up, not down. You look at the photon. It went left, not right. Before the measurement, both were real. After the measurement, only one survives. At least that's the Copenhagen view. It's elegant, but it raises disturbing questions. What exactly causes the collapse? Is it the act of observation? Is consciousness somehow involved? Or is collapse just a mathematical shortcut we invented to cover up something deeper? That something deeper is what the many worlds interpretation dares to reveal. Hugh Everett, a young physicist in the 1950s, argued that collapse never really happens. Instead, every possibility described by the wave function plays out, just not in the same universe. In his view, the universe continually splits, branching into parallel worlds where every possible outcome is realized. You don't just see the photon go left, another you sees it go right. You don't just win the coin toss, another you loses. At first, this sounded insane. Even Einstein reportedly dismissed it as fantasy. But mathematically, it's brutally consistent. No magical collapse, no special role for the observer, just the cold logic of the wave function unfolding across an infinite multiverse. Still, this comes with a cost. If many worlds is real, then the reality you call yours is not unique. It's just one thread in a cosmic tapestry. And while you feel like you're making choices, every possible choice is actually being made by some version of you, somewhere. This is the battleground. Collapse says nature discards possibilities. Many worlds says nature keeps everything. And here's where it gets even stranger. If branching is real, then the very experiment designed to prove collapse might, paradoxically, prove its opposite. What if the evidence already exists, hidden in plain sight, that we are splitting into infinite versions every moment without even realizing it? We're trained since childhood to think reality is solid. One world, one timeline, one version of events. You wake up, eat breakfast, go to work, make choices, and watch the consequences unfold. It feels linear. It feels absolute. But if quantum mechanics is right, if many worlds is even partially true, then this everyday picture of one reality is an illusion. Think about something as trivial as missing your train. In our ordinary mindset, you missed it, end of story. You'll never know what would have happened if you had caught it. But quantum theory whispers something chilling. You did catch it. In another universe right now, there is a version of you stepping onto that train, sitting by the window, maybe meeting someone who changes your life. From your perspective, you're stuck with one path. From the universe's perspective, all paths exist. This breaks the deepest assumption we hold, that events exclude each other, that if something happens, its opposite doesn't. But in the quantum world, either or becomes both and. A particle goes through one slit and the other. A photon travels two paths simultaneously. The math doesn't care about our common sense, and here's where it gets even stranger. If all outcomes exist, then you're not just you. You're an ocean of selves, each diverging with every quantum event. You feel continuous because your consciousness rides one branch. But just beside you, separated by an unimaginably thin quantum veil, countless versions of you are living out the alternatives. Some nearly identical, others shockingly different. Critics often say, but we don't see these other worlds. Isn't that proof they're imaginary? Not quite. Everett's point was that the branches don't interact. Once split, they evolve independently. That's why you don't bump into your other selves. They're like ghost channels on a cosmic radio, humming in silence just outside your frequency. And yet experiments show us hints that superpositions are very real. Electrons can interfere with themselves as though traveling two routes at once. Entire molecules have been put into quantum superpositions, behaving as though they exist in multiple states simultaneously. The illusion isn't in the math. The illusion is in our belief that only one version survives. So here's the unsettling truth. The universe may not be choosing one reality. We might be the ones trapped inside a single perspective, blind to the infinity unfolding just beyond our reach. But what if science could go further? Not just suggest the possibility of many worlds, but actually show us evidence that collapse is a myth and the multiverse is real. To decide between collapse and many worlds, we can't just rely on philosophy. We need evidence. Physics, after all, demands experiments. And while no one has yet opened a portal to another universe, there are clues, deep, puzzling clues, that push us toward one side of the debate. Let's climb the evidence ladder. Step 1, the double-slit experiment. This is the classic test that refuses to die. Fire single electrons at a barrier with two openings. Instead of choosing one slit, they behave like waves, creating an interference pattern as if each electron traveled through both slits simultaneously. Only when measured does the interference vanish, and the electron behaves like a particle. Collapse says, the act of observation forces the decision. Many Worlds says, no decision is forced. Both outcomes happen, and you only see the one in your branch. Step 2, decoherence. In the 1970s and 80s, physicists like H. Dieter Zay and Wojciech Zurek uncovered how fragile quantum states dissolve when entangled with their environment. It looks like collapse, but it's not. Instead of destroying possibilities, decoherence spreads them out, making different branches unable to interact. It's like dropping ink in water. The patterns are still there, but so dispersed you can't see them. Decoherence doesn't prove many worlds, but it shows we don't need collapse to explain why we only experience one outcome. Step 3, macroscopic superpositions. For years, skeptics said quantum weirdness only applied to tiny particles. But in the last 2 decades, scientists have placed entire molecules, thousands of atoms wide, into superpositions. In 2019, researchers in Vienna created interference patterns with massive organic molecules, far beyond the microscopic realm. The larger the system, the harder it is to dismiss. If superpositions can scale up, then why stop at molecules? Why not cats, people, planets, entire universes branching apart? Step 4, quantum computing. These machines, like Google's Sycamore processor and IBM's quantum devices, rely on superposition and entanglement to perform calculations. When a quantum computer runs, it explores a vast space of possibilities at once, collapsing into the correct answer only at the end. Some physicists argue this is indirect evidence for many worlds, that the computation happens across parallel realities. Others reject this as metaphor. But either way, the success of quantum computing proves superposition isn't just an abstract theory. It's a tool reshaping technology. Put all these steps together, and the foundation beneath collapse starts to wobble. The math doesn't need it. Experiments don't demand it. Decoherence, interference, and computation all work seamlessly without invoking collapse. Many worlds, uncomfortable as it sounds, remains brutally consistent. And yet, here's the haunting question. If parallel universes are real, shouldn't there be a way, however faint, to detect them? To actually feel the presence of another world brushing against ours? If many worlds is true, the consequences go far beyond physics. They hit directly at our sense of identity, freedom, and meaning. Because think about it, if every possibility exists, then nothing is truly unique. Every decision you make, from the person you fall in love with to the career you chase, isn't the only version of that story. Other versions are happening right now in parallel universes. The romantic notion that your life is a one-time event dissolves into an infinite repetition, endlessly diversified. Some see this as liberation. No choice is final. No mistake is fatal. Somewhere, another you got it right. But others see it as terrifying. If everything happens, does anything matter? If every outcome is guaranteed to exist, where is responsibility? Where is meaning? This is where critics strike. They argue that many worlds turns physics into metaphysics, producing a theory that explains too much. If all outcomes are real, then the theory becomes unfalsifiable. How do you ever prove or disprove something you can't interact with? Collapse theories, they insist, may be ugly, but at least they respect the boundary between physics and speculation. Yet defenders reply with equal force. Collapse theories often smuggle in mysteries of their own. What triggers collapse? Is consciousness special? If so, physics must bend to psychology, a deeply unsettling idea for science. Many worlds, for all its strangeness, keeps the rules of physics clean and universal. Philosophers add another layer. If parallel worlds exist, then so does a vast ensemble of yous. What does individuality mean in that context? You feel like a single mind, a single self. But the multiverse picture suggests you are more like a spectrum of selves, each carrying fragments of possibility. Personal identity becomes less about uniqueness and more about perspective. You are this version, living this story, but not the only story. Even ethics gets shaken. If every choice spawns universes, does morality matter? If in one branch you save a life and in another you don't, is one version of you virtuous while another is monstrous? Does your conscience apply only to the branch you inhabit, or does it echo across them all? And then there's the most haunting possibility. Maybe the multiverse isn't just a scientific model. Maybe it's the ultimate mirror of human longing. We dream of second chances, of different lives, of what if. Many worlds says those dreams are not fantasies, but realities, just beyond your reach. But here's the puzzle no one can quite escape. If the multiverse is real, then why this version? Why are you here, inside this branch, watching this video, and not another? So where do we go from here? Right now, the collapse versus many worlds debate feels abstract, a clash of interpretations. But the future of science may not allow it to remain a philosophical standoff. We are beginning to develop the tools to test reality itself. One frontier is quantum computing. These machines are still primitive compared to their promise, but every year, progress accelerates. If their power grows exponentially, some physicists believe they might not only process information, but also expose the underlying rules of reality. Imagine running algorithms so vast that their efficiency could only be explained if computations were spread across parallel worlds. If that evidence surfaces, collapse theory will struggle to survive. Another frontier is quantum gravity, the elusive union of Einstein's relativity and quantum mechanics. Right now, gravity seems classical, while quantum physics governs everything else. But what if collapse is tied to gravity? Some models suggest that mass itself might trigger wave function collapse, preventing macroscopic objects from existing in superpositions. If experiments confirm this, collapse gains a foundation in physics rather than mystery. If not, the door to many worlds swings open wider. Then there's cosmology. Our universe's expansion, dark energy, and the structure of the cosmic microwave background might carry fingerprints of quantum origins. Some researchers suspect that if inflation created our universe, quantum fluctuations could have spawned others, each with its own constants, particles, maybe even laws of physics. In that case, the multiverse isn't just a quantum curiosity, but a cosmic inevitability. But perhaps the boldest horizon is communication between branches. Most physicists say it's impossible, since decoherence seals off parallel universes. Yet fringe proposals suggest otherwise. Could entanglement leave faint signatures of interference between worlds? Could future experiments detect ghostly correlations that shouldn't exist in a collapse-only reality? If so, it would be the first crack in the wall separating us from our other selves. Beyond the lab, humanity faces the psychological test of these discoveries. If many worlds is confirmed, Our identity as a species changes forever. No longer the inhabitants of a single universe, but wanderers in an endless forest of realities. Some may embrace it as cosmic abundance, others may reject it as existential vertigo, but no one will remain unchanged. And here's the wildest possibility. What if, in the future, technology doesn't just prove the multiverse, but lets us choose our branches? What if physics evolves into navigation, a way to steer your path through the infinity of worlds? Let's step back from the experiments and theories. Forget wave functions, equations, and debates between physicists. Let's talk about you. What does this battle between collapse and infinite worlds actually mean for your daily existence? If collapse is real, then your life is singular. Every decision you make carries enormous weight because it eliminates alternatives forever. You are, in a sense, the author of a one-way story. Once you choose a path, the others vanish like smoke. That's comforting for some people. It means your choices matter absolutely. Your regrets are real, but so are your triumphs. You are the one and only you. But if many worlds is real, the picture changes completely. Every decision still matters, but in a different way. When you choose one path, another you takes the opposite. Somewhere, you are saying yes to the opportunity you rejected. Somewhere, you are walking down the road you avoided. From your perspective, you only live one line, but from reality's perspective, you are a branching river, endlessly splitting, endlessly flowing. This can feel paralyzing. If all possibilities exist, what does it mean to choose? Why strive, if success and failure both unfold regardless? But there's another way to see it. Many worlds doesn't erase meaning. It multiplies it. Every choice you make is still your experience. This version of you matters because you live it, feel it, and carry it forward. Just because another you exists doesn't make you any less real. Think of it like music. There are infinite possible songs, infinite melodies waiting to be composed. But the song you're hearing now still has power. It still moves you. It's not diminished by the fact that other songs exist. In the same way, your life is still precious, not because it's the only one, but because it's the one you're in. There's also a strangely empowering twist. If many worlds is true, then you are not locked into one fragile, finite existence. You are a vast network of selves, a chorus of possibilities. The version of you who failed isn't the only one. The version of you who succeeded exists too. And maybe, just maybe, knowing that can give you courage. Because even in this branch, even in this fragile line of reality, you can still act boldly, knowing that possibility itself is abundant. Collapse tells us we are unique authors. Many worlds tells us we are infinite actors. Either way, your life matters. But the meaning shifts depending on which universe you believe you inhabit. So the question is, which vision of reality do you want to carry with you when you wake up tomorrow? So where does this leave us? Standing at the edge of two radically different visions of reality. On one side, collapse, a universe that prunes possibilities, leaving behind one unique thread, your story, unshared, unmultiplied. On the other side, many worlds, a universe that refuses to discard, weaving every possible outcome into a cosmic tapestry so vast we can barely imagine it. We may never fully escape the mystery. Perhaps experiments will one day give us the answer. Perhaps technology will tip the balance toward collapse or toward branching. But right now, we live in the tension, and that tension itself is profound. Because whether your life is singular or infinite, the fact remains, you are here, conscious, watching, aware, carried forward by physics into this moment. Picture yourself walking through a library. You hold one book in your hands, the story of your life, the one you're reading day by day. Collapse says this is the only copy. Many worlds says the shelves around you are filled with alternate editions. The same title, but different pages, different endings. You can only read one. But knowing the others exist changes how you see the one you hold. That's the gift of quantum philosophy. It doesn't give easy answers. It reshapes the questions. It forces us to ask what real even means, and whether uniqueness or infinity makes life more valuable. So, what do you think? Do we live in a universe that collapses into one fragile story? Or are we drifting through an infinite multiverse of possibilities? Do you believe this quantum idea changes everything? Or is it just science fiction? Tell me below. Your view might change someone's mind.